Good day to Dr. Arif and my fellow friends. Today, we are going to present our experiment E1, which is half and full wave rectifiers. My name is Bonshun and the second team member is Muhammad Azam, and the third team member is Ivan Teo. Our objective of this experiment is to record and compare the input and output waveforms of a half and a full wave rectifier and rectifier with a capacitive filter.
For part 1, which is half-wave rectifier, the half-wave rectifier was constructed and tested using an oscilloscope. Channel 1 at point A to C as AC mode is used to measure the input, while channel 2 at point B to C as DC mode is used to measure the rectified output. Waveform, voltage and LED brightness were all recorded. For part 2, which is half-wave rectifier with filter capacitors with 22, 47 and 100 microfarad were added across the output. The effects on output voltage, ripple, waveform shape, and LED brightness were observed using the oscilloscope. For the third part, which is full-wave rectifier, the full-wave rectifier was constructed. The input and output waveform, together with the voltage value, were measured using an oscilloscope. At last, the LED brightness was observed for comparison. For the last part, which is full-wave rectifier with filter capacitor, the effects of different filter capacitors on output DC voltage, ripple, and LED brightness were analyzed using oscilloscope measurements. Now, I will make summarize for this experiment. For part 1 and part 3, they have no capacitor added, while part 2 and part 4 have capacitive filter added. For each DC level, part 4 have the highest DC level, followed by part 2, part 3, and part 1, which is half-wave rectifier, have the lowest DC level. For ripple size, part 1 have the largest ripple size, followed by part 2, part 3, and part 4, which is full-wave rectifier with capacitive filter, they have the smallest ripple size. For the LED brightness, half-wave rectifier have dim and flickering LED, and part 2 have the brighter LED. Part 3 have much brighter LED compared to part 2 and part 1, and part 4 have the brightest LED. So, for part 1, only positive half cycle produced, and part 2 have produced ripple to reduce with larger capacitance. For part 3, the frequency is doubled for a smoother. For part 4, we have the best filtering and performance.
Now we come to the discussion. In part 1, the input waveform was a clean sinusoid, and the output shows only the positive half cycles. This confirms the half-wave rectification. The output RMS voltage dropped and peak-to-peak voltage reduced because the negative half cycle was completely blocked by the diode. The LED flickered visibly due to a large pulsating direct current component. When the filter capacitor was added in part 2, the output became smoother compared to part 1. With the increasing capacitance, the average DC current increased and approaching the theoretical peak value, 18 volts. The VRMS and VPP decreased, and the 100 microfarad capacitor gave the smoothest output and the steadiest LED brightness. Thus, the larger capacitance will store more charge and better reduce the ripple. In part 3, the full wave rectifier produced twice the frequency and higher output voltage. VRMS increased because both positive and negative half cycle were utilized. The ripple amplitude remained similar, but the average DC level was clearly higher, resulting in a brighter and less flickering LED. In part 4, the combination of full wave rectification and capacitive filtering produced the best DC output. This is because average DC voltage reached almost the peak value, which is 18 volts. The ripples were dramatically reduced. With 100 microfarad, the ripple was almost negligible, and the LED glowed steadily with maximum brightness.
In conclusion, half-wave, low efficiency, high ripple, flickering LED. For full wave, double the frequency, higher average voltage, better performance. Adding a capacitor, especially 100 microfarad, significantly smoother DC and much higher usable voltage in both cases. Best performance, full wave rectifier plus 100 microfarad capacitor, highest DC voltage, lowest ripple, steady bright LED. The result fully agree with theory. Full wave rectification with capacitive filtering is far superior, more converting AC to stable DC, which explains its widespread use in power supplies.